Let's go ahead and study mean absolute deviation. We're going to explain what the mean absolute deviation is and just show us how to calculate the mean absolute deviation. So the mean absolute deviation is the average distance between each data point and the mean. It gives a measure of how variable the data set is. And so the mean absolute deviation is the sum of the specific data point, the sum of the difference between each of the data points and the mean divided by the number of data points that we have. So let's look at the different steps that we have to follow to get the mean absolute deviation. The first thing we want to do is calculate the mean of the distribution. Then we want to calculate the difference between the mean of the distribution and each of the data points or the numbers in the distribution. And then we want to get the absolute value of each of the numbers from step 2, and then calculate the mean of the absolute difference. So let's put that to practice. So we have this table here to kind of make it easy for us to see. So let's go ahead and fill out the data with the numbers that we have. We have 5, 12, 19, 4, 23, and then 33. So let's get the mean of those numbers. So let's look at the mean is going to be 5 plus 12 plus 19 plus 4 plus 23 plus 33 divided by, let's count, 1, 2, 3, 4, 5, 6 divided by 6. So what we have here is 5 plus 12, that's 17, plus 19, we have 36, plus 4, we have 40, plus 23, we have 73, 40 plus 23, we have 63, plus 33, we have 96. So 96 divided by 6, which is 16. So our mean of this distribution is 16. So now what we have is 5 minus 16, which is negative 11. 12 minus 16, we have negative 4. 19 minus 16, we have 3. 4 minus 16, we have negative 12. 23 minus 16, we have 7. 33 minus 16, we have 17. Now we get the absolute of each of these, so this is going to give us 11, 4, 3, 12, 7, and then we have 17. So here we now get the x minus is going to be the absolute of the data value minus the mean divided by the number of terms. So let's look at that. We have x minus mean over n. That's going to give us 11 plus 4 plus 3 plus 12 plus 7 plus 17 divided by 6. So we have 11 plus 4 at 15, plus 3, 18, plus 12, we have 30, plus 7, 37, plus 17, we have 54 divided by 6, which is going to give us 9. So the mean absolute deviation just gives us that on average, the numbers in the distribution is about 9 units from its mean. Let's try this data set here. We fill out the data set, we got 15, 7, 3, 22, 1, 41, 16. First thing we're going to do is get the mean. So the mean is 15 plus 7 plus 3 plus 22 plus 1 plus 41 plus 16, and we divide this by 7. So this is going to give us 15 plus 7, 22 plus 3, 25 plus 22, 47 plus 1, 48 plus 41, 99 plus 16 is 115, and then we divide that by 7. So this is going to give us approximately 16.4. So 15 minus 16.4, we have negative 1.4. 7 minus 16.4, we have negative 9.4. 3 minus 16.4, we have negative 13.4. 22 minus 16.4, we have 5.6. 1 minus 16.4, we have minus 15.4. 41 minus 16.4, we have 24.6. And 16 minus 16.4, we have minus 0.4. So now let's get the absolute of each of these values. So here we have 1.4, 9.4, 13.4, 5.6, 15.4, 24.6, and 0.4. So we're going to add all this together. So this is going to be the absolute right here. So the absolute of x minus its mean divided by n. So we have 1.4 plus 9.4 plus 13.4 plus 5.6 plus 15.4 plus 24.6 plus 0.4, and then we divide that by 7. So this is going to give us 70.2 divided by 7, which is about 10.03. So for this distribution, this is the average distance between the numbers and the mean of the distribution.